Dear students, in this class we will discuss the important concept concerned to motion in a plane. The concept is projectile motion. Let us see. Projectile motion. Projectile motion, it is also called as the motion under gravity. Motion under gravity, and it is a two-dimensional motion. Students, to understand the concept of projectile motion, now let us take a plane. We are calling. See here students, this spikeboard looks like a plane. Correct? Projectile motion means any body projected with initial velocity and allowed to fall under gravity, that we are calling projectile motion. Shall I take a plane? I will take a plane. Look at me. See here, this spikeboard looks like a plane. In this plane I will take, this is the y-axis, right? This we are calling x-axis, right? This we are calling the origin, right? To understand the concept of projectile motion, let us take an object. An object projected with initial velocity from the origin. See here, this is nothing but one object I will take here. When object is projected at this point, projected, how it is projected? The object projected near the earth's surface and move along the curved path under action of gravity, like this, right? For example, let us take a cricket ball. How this is? When cricket ball throwing from this point, how it goes? The cricket ball goes like this, right? Or when a batsman hits the cricket ball, how the cricket ball goes actually? The cricket ball goes like this, right? Or I want to throw any one object toward the students. How the object can go? The object goes like this one, right? What you are calling? Actually, this is nothing but object. How the object can go? Object can go in this path. Object like this path. Object may reach at this point. Again, how it go? It may go like this, like this, like this. It may, right? When object projected with initial velocity, the object move along the curved path under action of gravity. Under action of gravity. This we are calling projectile motion. Then, by knowing this, how to define the projectile motion? Projectile motion means when object projected near the earth's surface and move along curved path under action of gravity. Actually, how the gravitational force is there? How the gravitational is there? Acceleration due to gravity always acting in downward direction, that is minus z value, right? Due to this gravity, this object move along curved path, under action of gravity, right? Mean due to gravitational force, this object move like this one, right? How this object moves? This object moves with initial velocity. This is nothing but initial velocity. This is the initial velocity u, and how it reaches? How much velocity is projected, that much velocity it reaches at the same point. This we are calling projectile motion, right? Then how to define the projectile motion? Shall we see here? What is the projectile motion? When object projected near a surface and move along curved path under action of gravity. This we are calling projectile motion. Shall I write the definition? How this is? The object, an object projected near a surface, and moves along curved path, under action of gravity, is called as projectile motion. is called as projectile motion, right? Because this object throwing near the earth surface, and how it is falling? It is falling due to gravitational force, or we are calling gravity, right students? Then see here, when object projected not the vertically, not the horizontally, here not it is projected along the horizontal, along the vertical. How it is projected? The object projected at an angle theta less than 90 degree and greater than 0 degree. To reach the projectile motion, what we should do? Object must be projected by an angle greater than 0 degree and less than 90 degree. How this is projected? Look at me. This object projected with the horizontal by what angle? This angle, this angle. This angle we are calling angle of projection. This angle we are calling angle of projection. And the object projected, whatever object projected, this object we are calling, this object we are calling projectile. What are calling? Projectile. Look at me here. See here, this is the object projected, this object projected, the object which is projected, this we are calling projectile, right? And whatever the path followed by the projectile, this we are calling trajectory. What are calling? Trajectory. Whatever distance traveled or whatever the path followed, this is the path followed by the projectile. This we are calling trajectory, right? What are calling this? This we are calling trajectory. Trajectory, right? And what are calling? This object. This object we are calling projectile. This we are calling projectile. And whatever the path followed, this we are calling trajectory, and the trajectory looks like parabola. How the trajectory looks like? The trajectory looks like a parabola because this is the shape of the parabola. But students, when object projected with an initial velocity and angle of projection theta, at every point of the projectile motion, the velocity of the projectile resolve into two components. One component is along horizontal component and another component is along vertical component. Already we have seen in the last class how the vector can be divided into two components, that is rectangular component of resolution vector we have seen, right? In similar way here, when object is projected with initial velocity u, this can be resolved along horizontal and vertical. How this is possible? Look at me. At this point, this is nothing but initial velocity u. This initial velocity resolved into two components. One component is nothing but ux, and along the vertical component, that we are calling uy, right? Along the horizontal component, ux can be replaced by u cos theta, right? And along vertical component, uy equal to how much? U sin theta, right? How this is? At every point, not only this one, shall I take at this point it can be, what about this one? This is nothing but initial velocity u, right? How this is resolved? This can be resolved along horizontal component and vertical component. What are calling? This component is nothing but u cos theta. What about this component? This component we are calling u sin theta. Alright students. Again at this one, shall I take? At this one, this is nothing but velocity. Shall I take? This is nothing but velocity. U I will take. Right. Again this will be resolved into two components. One component and second component. What are calling? This we are calling u cos theta. What about this final velocity? Here final velocity I am taking 0 here. I will explain this one later. Right. Again similarly at this point, this is the one component. This is the second component. What are calling? This component is nothing but u cos theta. What about this component? U sin theta. What about this? This is the resultant component, resultant velocity. Similarly at this point, this is the horizontal component. What are calling? Vertical component. What about this one? This is nothing but resultant. U I can take. This we are calling u cos theta. How much? This is u sin theta. Right or right students? I mean, by what angle it is projected, by same angle it reaches on the earth surface. One thing, fine. By how much initial velocity projected, but that much velocity it reaches to the ground. Remember this point. These are very important. Important point is, at every point the velocity of the projectile resolved into two components are u cos theta and u sin theta. right? And one thing, by what angle of projection it is projected, it reaches to the same angle. One thing, and by what velocity it is projected, it reaches to the same velocity. But remember students, one point is there. During the projectile motion, the angle of projection may change. Vertical velocity of the projectile may change, and displacement changes at every point. This is very important. What I am going to say? During the projectile motion, here so many physical quantity changes. I mean, except this point and this point. Initial point and final point. At that, so many physical quantity changes. The quantities are, when projectile goes from this point, gradually vertical velocity will change, decrease, displacement will change, angle of projection will change, so many physical quantity will change. Now students, let us discuss what are the component of the velocity u cos theta and u sin theta, how they will change. Now we will see students. How velocities are resolved and how u sin theta changes and how u cos theta remains same. That we will see. Now shall I take the one more idea? Again I will take the same plane. Look at this, we are calling the plane, right? This is the y-axis. What are calling x-axis? This is nothing but the origin of how the object is projected. The object projected in this fashion. Object projected like this. This we are calling projectile motion, right? How the object is projected. This is nothing but object. What I can call O point is that this is the position of the object, right? This we are calling the position of the object, right or wrong? We said that during the projectile motion, at every point the velocity can be resolved into two components. Shall I see here at this point how this is? At this point the component, what is the component? The component is nothing but ux equal to u cos theta. What about at this point? What is the velocity? Velocity uy equal to how much? U sin theta. Right students? Now at this point again, what about this? This we are calling the resultant velocity. Shall I take? This is the resultant velocity. Again there can be added a parallelogram of additional vector. What value? This is the u value. This is what we are calling angle of projection theta. Right? At this point also, velocity can be resolved. This is the u cos theta. What about this? U sin theta. Shall I take? This is the resultant component u. What about this? This is u cos theta. How much this is? U sin theta. What about this u? Right. Similarly, at this point, what happened? At this point, the velocity can be resolved. How much this velocity? This velocity u cos theta. What about this? U sin theta. Actually, here final velocity is there. Final velocity I am making Vy equal to 0. I will explain this. Similarly, shall I take this point and this point? Finally, shall I take at this point? Look at me. What are calling u cos theta? This is u sin theta, right? What about this? U. By what angle projected? Same angle will reach. By what speed projected? Same velocity will reach us at this point. But here, velocity resolved into two components. One component is u cos theta. Let us discuss about u cos theta. Actually, students, how acceleration due to gravity acting? Acceleration due to gravity always acting in downward direction. This is the direction. This we are calling minus v. In this direction it is acting. What are calling acceleration equal to acceleration due to gravity? Because any body freely falls, it moving with constant acceleration, uniform acceleration. Projectile motion is an example for uniform acceleration. Because when body projected, either it is projected vertically or it can projected with an angle theta. How it is goes? It goes with uniform acceleration. And for freely falling body, a equal to z in downward direction. Body goes like this in downward direction. A is equal to minus z value I will take. Right. Now, let us discuss about u cos theta, horizontal component of the projectile. Horizontal component velocity of the projectile. See here. Actually, shall I take z here in this manner? Z I will take. Actually, how the z is acting? In this direction z is acting. What are calling? This we are calling u cos theta. Shall I call this? This is nothing but u sin theta. What is angle between them here? How much? This is 90 degree. Right. Shall I take here instead of this one, instead of this u cos theta, shall I take it as z? It is z cos theta. What about this? Shall I take this? This is nothing but z sin theta. Right. How velocities are there? Velocity equal to u cos theta. Here how much velocity? Velocity equal to u sin theta. Look at the z component. Angle between them how much? 90 degree. Cos 90, 0. Z value how much? 0 here. I mean, along the horizontal component, no acceleration due to gravity is acting. Following my point, students? How the z is there? Along this direction. You put theta equal to 90, cos 90, 0. 0 into z, that becomes 0. But what about here? Put your theta equal to 90 degree. Sin 91, what is remaining? Z value remaining. I mean, along the horizontal component, along the horizontal direction, no acceleration due to gravity is acting. No acceleration due to gravity. Due to no acceleration due to gravity along the horizontal direction, the component u cos theta that remains same throughout the motion of the trajectory. And ready? U cos theta ಮೇಲೆ acceleration due to gravity ಆಗ್ತಾ ಇರುವುದಿಲ್ಲ. ಆವಾಗ ಏನಾಗ್ತದೆ? ಈ u cos theta ಇಲ್ಲಿಗೆ ಎಷ್ಟು ಇರ್ತದೆ? ಈ ಪಾಯಿಂಟ್ ಒಳಗೂ ಅಷ್ಟೇ ಇರ್ತದೆ, ಈ ಪಾಯಿಂಟ್ ಒಳಗೂ ಅಷ್ಟೇ ಇರ್ತದೆ, ಹಾಗೆ u ಪಾಯಿಂಟ್ ಒಳಗೂ ಅಷ್ಟೇ ಇರ್ತದೆ. Throughout the journey of the projectile motion, u cos theta component of projectile along horizontal direction that remains same at every point. Because no acceleration due to gravity acting. But one more is there. What about vertical velocity here? What about vertical velocity? What is the vertical velocity? Vertical velocity u sin theta, u sin theta, u sin theta. We are calling vertical velocity. Students, shall I draw one more diagram here? How to take the u sin theta? Look at here. I will show how the u sin theta will change. Right. See here. How to explain this? Again I will take, this is the plane, right? This we are calling x-axis, y-axis, right? How the projectile goes? The projectile goes like this, remember, right? By what angle of projection? Theta is nothing but angle of projection. The projectile is projected like this. This point projectile is there with initial velocity u. At this point projectile, at this point projectile. Similarly at this point, projectile available. What we say? At every point, velocity can be resolved. This one we are calling u cos theta. This we are calling u cos theta. Similarly, how much? U cos theta. What about this again? This again u cos theta. Right? What about this? U cos theta. Right? U cos theta. U cos theta remains same. But what about vertical velocity? Here, shall I take? Vertical velocity how much? This is u sin theta. What about this? This is u sin theta. U sin theta. Here how to take? This is nothing but final velocity here that I am taking Vy. Vy equal to how much? Vy equal to uy sin theta. Final velocity at this point. Right? Students, when object is projected from initial point, initially the component u sin theta gradually decrease. U sin theta gradually decrease because acceleration due to gravity, how it is acting? Acceleration due to gravity at every point, it is acting in downward direction. It is acting in downward direction. How it is? Z acting in this direction, downward direction. Due to acceleration due to gravity, u sin theta gradually decrease and exactly at the highest point. At the highest point, the final velocity, final vertical component of the velocity, that becomes 0 because exactly at the highest point, acceleration due to gravity and u sin theta both are acting in equal and opposite direction. That's what at the highest point. At the highest point, final velocity, final vertical velocity of the projectile becomes 0. From it where? From this point to this point, gradually vertical velocity decrease. At this point it becomes 0. For example, shall I take the vertical velocity? I will take here 4. How much it is actually? Shall I take here? Vertical velocity here 4 is there. How much? This becomes 2. This becomes 1. Right? At this point exactly, vertical velocity is 0. Initially 4 meter per second vertical velocity was there. It becomes 2. It becomes 1. Finally at this point, this becomes 0. Right? I mean, from angle of projection to highest point, vertical velocity gradually decrease, and at this point the vertical component of the velocity becomes 0. Final velocity becomes 0. Again from this point to this point. From highest point to ground, what about vertical velocity? From highest point to ground, vertical component of the velocity gradually it is increased. Here at this point, at this point, at this point, again at this point, it reaches the maximum value. Because how it is the g acting in downward direction. In this case, the vertical component of the velocity increase because g helps to increase the variable velocity. Directly, I mean, when projectile reaches from this point to this point, vertical component of the velocity increase, and from this point to this point, vertical component of the velocity will be decreased. Because from this point to this point, acceleration due to gravity oppose the vertical component of the velocity, one thing, and from highest point to the ground, vertical component of the velocity will be increased because acceleration due to gravity helps to increase that velocity. So these are basic things concerned to vertical component of the velocity. I mean, during the projectile, horizontal component of the velocity that remains same, vertical component of the velocity gradually decrease initially, then after it will be increase. Important point is, at the highest point, vertical component of the velocity becomes 0. Remember this point, students. But during the projectile motion, we have to learn the special physical quantities. The special physical quantities during the projectile motion, that we'll see. See you, students. Right? Now students, these are basic things what I learned before this. Now we will see some physical terms concerned to projectile motion. In detail we will see now. Right? Now students, again I will take a plane again. This is the plane. Right? This is the plane I am calling. This is the origin point, x axis and y axis respectively called x and y axis. From this point, how the object is projected? From this object is projected near the earth surface and move along the path, fall to under action of gravity. This we are calling projectile motion. Right? See here, this is the projectile position. What I can call projectile position. These are the respective projectile positions. Right around. Right, students. Shall I take only the one point here? Here at this point, velocity is nothing but u cos theta, that remains same throughout the journey. What about this? This is nothing but u sin theta. Right? What about this? This is nothing but resultant velocity u I can call. See here again, here similar, here also possible. This becomes what? U cos theta, u sin theta. U sin theta, what about this? Resultant velocity u. This is what we are calling angle of projection. At this point, what happened? At highest point, at this point, velocity u cos theta remaining. But at this point, what is vertical component of the velocity? Vertical component of the velocity becomes 0. Vy becomes 0. Right? See here. What are calling this? This we are calling trajectory of the projectile. Trajectory means path followed by the projectile. Students, mainly we are defining 3 physical quantities. One is nothing but time of the flight, second one is the maximum height, and third one is nothing but range or a horizontal range. See here, what are 3 physical quantities? One we are calling time of flight. Time of flight. Time of flight. Second one is maximum height. Maximum height. And third one is horizontal range. Horizontal range. horizontal range. See, let us see one by one terms. What is time of flight? We will see expression of the time of flight. Then after we will see maximum height. Finally we will see horizontal range. Let us define time of flight and we will obtain the expression for the time of flight. Right. Time of flight means the time taken by the projectile to complete its path, or time taken by the projectile to complete its trajectory. This we are calling time of flight. Are you following, students? What I am going to say? Time taken by the projectile to complete its trajectory. This we are calling time of flight. Let us see how the time of flight can be obtained initially. Shall I go one by one? First of all, I will go directly for time of flight. Time of flight. On how to achieve the expression for the time of flight. See here. Time of flight. Capital T I can call. Here, what is time of flight? Time taken by the projectile to complete its trajectory. This we are calling time of flight. How to define? Time taken. Time taken by projectile. Time taken by projectile to complete. To complete it's a trajectory is called as time of flight, is called as time of flight. Time of flight. See here how to obtain. The time of flight can be achieved in two ways. One is, shall I go for directly? I will go from this I am calling. This I am calling A point, this I am calling B point, and this I am calling C point. Right. Look at me, students, what we said, that at highest point, vertical component of the velocity becomes 0. Now let us discuss when an object goes from A to B. Object goes from A to B. Right. We know that this equation V is equal to how much? V is equal to U plus AT, equation of motion. Right. But here, this is nothing but freely falling case. Projectile motion is an example for freely fall. For freely falling, shall I take? For freely falling vertical, I am discussing from A to B. See here. At B point, V can be replaced by Vi. This is equal to 0 because at the highest point, vertical component of the velocity becomes 0. Right. Then A can be replaced by minus Z. Right. Then I will take the T can be replaced by TA. What is TA? TA represents time of ascent. Time of ascent means time taken by the projectile to reach its maximum height. This we are calling time of flight. I mean time taken from ground to maximum height. That we are calling time of ascent. Right. Then by putting all these values, how to take here? See here. V can be replaced by Vi. And what about U can be replaced by along vertical component. How much? This is U sin theta, because we are discussing about vertical component here. Right. Then look at me here. U can be replaced by what value? U sin theta. Right. A can be replaced by minus Z. And T can be replaced by time of ascent. Right. But vertical component at the B point, that becomes 0. Then shall I take here? 0 equal to how much? 0 equal to U sin theta. U sin theta minus Z into how much? TK. Right. Directly how to write? TA equal to time of percent equal to U sin theta divided by Z. U sin theta divided. This we are calling time of ascent. From where to where? From the position A to B. Right. Then what comes from B to C? time taken to reach from ground to maximum height we are calling time of ascent, and time taken from maximum to reach the ground level, this we are calling time of descent. If this we are calling time of ascent, this we are calling time of descent. How much time taken from A to B, same amount of time taken from B to C also. Directly what you can call the time of ascent. Time of ascent must be equal to time of descent, right? Then shall I do the time of descent directly? The time of descent can be written how much? Again u sin theta divided by how much? That is g value. But what is time of flight? Time taken to complete its trajectory from this point to this point we are calling TA, from this point to this point we are calling PA. What is the time of flight directly? Shall I write here? The time of flight can be written the sum of time of ascent plus time of descent. What is time of ascent? See here, time of ascent equal to u sin theta divided by g, right? Then again time of descent equal to how much? Again u sin theta divided by z. Then finally what is the time of flight here? The time of flight equal to how much? T equal to 2u sin theta divided by z. This we are calling time of flight. Right students? Time of flight means time taken by projectile to complete its trajectory. But the time of flight you can achieve by alternating manner also. Shall I tell how the time of flight can be achieved by alternating way? Look at me here. See here. Let us discuss this. This can be achieved by alternating way also. See here. The object is projected from what point? Object to projected from A point and reaches to the C point. As compared to A and C. As compared to A and what is A and C? Time taken to start and time taken to end. This we are calling total time of flight. If we compare the A and C point, the object does not move along vertical. Here no vertical distance traveled as compared to A and C. See here. Shall I take one more equation here? Look at it. What is the equation? S is equal to how much? S is equal to ut. S is equal to ut plus half at square. Right. I will take along vertical direction. Along vertical direction, S is equal to y. Along vertical direction, we'll say S is equal to y. Along the vertical direction, u can be replaced by u sin theta. Right. Then time can be replaced from A to C. Time of flight from A to C I am discussing. From A to C. See here. Then again A can be replaced by what value? Minus z. Right around. Now students, if we compare the A and C, there is no vertical distance travelled by the projectile. If we compare, ನೀವು A ಮತ್ತು C compare ಮಾಡಿದ್ರೆ object ಇಲ್ಲಿಂದ start ಆದ ಇಲ್ಲಿಗೆ ಬಂದು end ಆಗಿದೆ. I mean along if we compare A and C point, there is no vertical distance travelled because from A to C how much time taken we are going to calculate. ನಾವೇನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ A ದಿಂದ C ಗೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಂಡ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ right? Then along the vertical direction y must be equal to 0. Along the vertical direction, if we compare A and C, no vertical distance here. That's what I will do directly. Shall I take S is equal to y? I will put directly here only. S equal to y equal to 0. Along vertical direction, put all these values. Y equal to u can be replaced by u sin theta. T can be replaced by capital T. Right. A can be replaced by minus z. Then how this is? Minus half gt square. Along vertical direction, displacement is 0. What is remaining then? U sin theta into t minus how much? Half z of how much? T square. So remember this. Bring this side. What are we getting? Half z into t square equal to how much? U sin theta into t. Right? 1 t get cancelled. What is remaining then? Z of t whole divided by 2 equal to how much? U sin theta. Right or how to get? See here from this one. T equal to how much? T have to write there. T equal to 2 2u sine theta divided by how much? G value. The same result we got as we explained previously. Then what is the time of flight here? The time of flight can be written 2u sine theta divided by how much? G value. 2u sine theta divided. Here 2 is constant, the initial velocity constant, and G is constant. What is the variable? Angle of projection is the variable. Angle of projection at this point it is maximum and at this point it is maximum. But as the object goes, projectile goes from this point, gradually angle of projection will change. Angle of projection will decrease gradually. And from this point to this point it decreases, again from B to C it will be increased. Right? One more physical quantity we will see, that we are calling maximum height and horizontal range. Students, this concept we will see in the next class. Thank you.